Okay, welcome back. This is now session 16, and I repeat, session 16 in regards to mathematics GCSE Key Stage 4. Now, you need mathematics if you're going to be an electrician or training to be an electrician. There's no way around that, okay? Now, what I want to look at is accuracy. And one of the things that we need to look at and consider in regards to mathematics is how accurate our answer needs to be. Okay, so we can see here when you are working out answers to problems using your calculator, you will often find that the display shows numbers with 8 figures, digits in them. For example, 35.615429. However, answers do not usually need to be so accurate, and in many cases it would be misleading to give answers with all the figures included. Okay, so what I want to look at is basically explain to you that when we're dealing with numbers, it's important that we come to a certain point of accuracy that is acceptable worldwide and universal. Okay, sorry, but I'm trying to make sure that it's in frame. Let's look at a work example. A party of cyclists went on an outing and the total distance that they traveled was 50 miles, measured to the nearest mile. After completing 1/3 of their journey, they stopped for a break. How many miles had they traveled when they stopped for their break? The solution, we look at the 50 because we were taking the 50 miles, they traveled 50 miles. And they completed 1/3, so 50 miles divided by 3, that's where our 3 comes from, okay? So let me get my pen so we can see what we're talking about. Okay, good. That's our 50 here, okay? And they covered, measured to the nearest mile after completing 1/3 of the mile, and this is they completed 1/3 of the mile. 1/3 of the, sorry, 1/3 of their journey. My apologies. 1/3 of their journey. Okay. So 50 divided by 3 is what we have here. Okay. And that's going to give us an answer here of, let me just change my color of my pen. Give us an answer here of 16.66667 miles. Now, do we really need it to be that sillily accurate? No, we don't. So, is your answer really so accurate? It's not. So, what we look at, is your answer really so accurate? Well, not quite. But since the total distance was only measured to the nearest mile, this answer cannot be so accurate. Okay? The answer is best given as distance traveled equals 17 miles. Now, the reason why we look at it from that perspective is that 16.66, you're rising nearer 17 rather than 16, aren't you? Okay? So as we look at this now further, you can see that why is the answer 17 and not 16? If you look at the numbers on the number line, you can see that 16.666667 is nearer to 17 than 16, and here is our number line, and you can see that is the case. Okay, it's nearer 17 than 16. Okay, you're too far away from 16 for it to be actually 16 at all. Okay, now this process of approximating answer is called rounding. And let's get that word out for you. It's called rounding. Okay, rounding. Okay, not grounding, rounding. And there are rules to make it easy for you. So let us look at these rules. These rules depend only on the value of the figure immediately to the right of the last figure, which is to be kept, which is that number after your decimal point. If the number is less than 5, round down. 5 or more, round up. Okay, and it is as simple as that. Remember this. Let's see if we can make it a bit brighter for you to see. Okay, and bright and strong. Okay, yeah. This is where we are. Okay, and that is the rule. You must comply with this rule. Less than 5, round down. 5 or more, round up. Okay. Okay, let's just get it into focus. Okay. Now let us look at the problems of rounding the following to the nearest whole number. 13.27. Now in each of these examples, we need to lose all the figures to the right of the decimal point. So A, and that's the one we're looking at here, okay? And that is A and here as well, and this is response to this. That is linked to here, okay? Okay. Right. Now 2 is less than 5, so we round down. So here you're going to round down. That is leave the 3 unaltered, okay? Therefore the answer here is 13. Okay, that's our answer, 13. Now, this little symbol here means approximately equal to. Now B, 8.62. So here 6 is more than 5, so we round up. That is add 1 to the 8, bringing it to 9, and that is our answer, equal to. Okay. Now, (17.4) If the number is 5, we round down. If the number is 5, if the number is 5, we round up. If it's less than 5, then you will round down. So here we're going to round up. So therefore, this should be 18. Okay. Practice that. Now practice. Now, work example. Find the area of a rectangular lawn measuring 8.4 meters by 6.3 meters, giving your answer to the nearest square meter. Now, the first thing you need to look at is to multiply this out, isn't it? So let's now come back to here. Let me change my pen color again. We go back to here. So we got this 8.4 times 6.3 meters. Okay. Area of lawn. Okay, so when you multiply this out, you get 52.92 meters square meters. So therefore, 9 is way above 5. So this, you will round this down to, I apologize. You will round this up to 53 meters square. Again, 53 meters square, so you're rounding up. Okay? And that would be your answer here. Okay? That would be correct. Now again, take the time out to do this for yourselves. Okay? And again here, to the nearest whole number, you would be rounding up. okay, and that will equal 1000. Okay, in some problems you will need to give answers as whole numbers without being instructed to. However, it is not always correct to take the nearest whole number, as you can see in the following work example. Okay, so here we have Bill is planning a party for his son and 12 of his son's friends. He calculates that each child will drink 3 cups of lemonade. If a bottle of lemonade holds 2 liters and each cup holds 118 cubic meters, how many bottles will he need to buy? Well, so the solution, now let's extract, now here we take out the information that we need. We have 12, okay? 3 2 liters, how many bottles will he need to buy? Okay, so the number of cups, now here it's very interesting to see because it tells you in the question, Bill is planning a party for his son and 12 of his friends. Now you have to take into account 12 of his friends plus his son makes 13. So you can see that the 13 is here and it's made up by his son's friends and his son and his son's friends, okay? And that's his son. That gives us our 13 people. Okay, that's 39. Volume of lemonade needed equals 39 times 118 cubic centimeters equals 4,602 cubic centimeters. Now here we know that 1 liter equals 1,000 cubic centimeters. 1,000 cubic meters. I don't know why I got centium on the brain for heaven knows. Okay, so therefore when you divide that, you can see that now therefore 4,600 to divide cubic meters I'm not quite happy about this cm cubic meters, but we'll go with it as standards because I must have done that for a reason, but nonetheless we'll see. Uh, Feel free to look at this differently to how I'm looking at it. Okay, because questioning myself here. But now here we have 2 liters. So 2 liters equals 2,000 cubic meters, and that comes from here. Okay, that goes to that. That is this here. Okay. Okay. Now, Bill will need to buy 3 bottles. Okay, because it's going to be more than 2. So he's going to round it up. He'll need to get 3 complete bottles as we don't sell half bottles. Okay. The answer has to be given as a whole number. You cannot buy 0.3 or 1 of a bottle. In this case, you do not take the nearest whole number. Common sense tells you that he will need more rather than less. Okay. So let's make sure that you've got that. Okay. Okay. We just move this back. Okay. Center. Now again, here we have worked example. A pet shop buys fish food in 5-pound bags and resells it in 100-gram packets. How many packets will they be able to sell from one bag? So we're going from pounds to grams, and we know there's 2.2 pounds to 1 kilogram. So here's our information. The 5 we need, okay? The 100 we need, okay? And we have the 1 here, okay? Now we need to divide 5 by 2.2 because 2.2 there is 2.2 pounds in 1 kilogram. Okay? So let me write this here for you, okay? Pounds in 1 kg. Okay? Okay, don't forget that. So here we have now 2.272727 repetitively. Okay, or you can look at this from the perspective of 1 kilogram divided by 2.2. Okay, but 1 kilogram equals 1,000 grams. So we have here 2.2 kilograms. So we want to bring this to 1,000 now. So if we move the decimal place 1, 2, 3 places to the right, it'll give us 2,272 grams. Number of packets with 100 grams in each. So we now have 2,272 grams. That you will divide that by 1,000, and remember where you got your 100 from. Your 100 came from here. Okay. Yes, sir. Okay. And that will give us 22.7272 packets. But we really can't go no further than that. You could round it up to 23, but then have you sold 23? And we need to comply with the question. Pet shops buys fishing food in 5-pound bags and resells it in 100 gram packets. Many packets will they be able to sell from one bag? The amount of packets you'll be able to sell from one bag is actually 22, and this will be your answer here. Okay, we can't round up anymore because he would only have sold 22. He would not have sold 23. And since only 4 packets can be sold, we must round down. Okay, so far all the examples we have looked at have involved rounding to a whole number. However, there are many problems where we want to approximate answers but not to a whole number. There are 2 ways of specifying the accuracy of answers. We can use decimal places or significant figures. And this is what I wanted to look at next time round, is to work examples in regards to decimal places. Okay? And we'll stop there for now. Ample time, I believe. Okay, and we can look at that in a different manner. Okay. Okay. That'll be it for now. Thank you, and do have a good day. Bye bye.